Imagine you are a network engineer for a major telecommunications provider responsible for optimizing data transfer over your fiber optic network. Data packets arrive at the network interface randomly with an average rate of 10,000 packets per second. Each packet requires an average processing time of 0.001 seconds to be routed and forwarded. Currently, you have one dedicated processing unit handling all data traffic. In this video, I'm going to calculate the buffer size, which is the queue length for incoming data packets. So we are given that information there. And the first step is to extract what we are given. So I'll start by looking at the 10,000 packets per second there. 10,000 packets, it's the average rate of arrival. That will be our lambda there. So we have lambda is equals to 10,000 per second. We are also given that each packet requires an average processing time of 0.001 seconds to be routed and forwarded. So this is the time spent in the queue plus the time spent being saved. So what we are having there, that's the SGN time. So I can go on and write that the SGN time, E of S, is equals to 0.001. Then go on and look at what we are asked to calculate there. We are asked to calculate the average buffer size, the queue length. And the only formula that can link the queue length to the arrival rate and the SGN time is little slow. Little slow states that the average queue length is equals to lambda multiplied by the average SGN time. So we substitute the value of lambda that we have here and the value of the SGN time that we have here, so that we have the average queue length is equals to 10,000 multiplied by 0.001. 10,000 multiplied by 0.001, it gives us a 10. So what we are having there is the average buffer size is a 10, and we used a little slow to get that result.